Hello, my name is Cam. I'm in grade 10, and the goal of my project is to design and build a bike-powered generator that can charge a phone. I chose this project because I am interested in the way we generate energy, and if I wanted to understand it, I would need to expand my knowledge about electronics, motors, and generators. The way we generate energy is more important than ever with climate change at our doorstep. Electric motors and generators work essentially the same way. Every generator and electric motor has a stator and a rotor. The stator is the stationary part of the motor and is made up of many copper coils. The rotor is a part of the motor that rotates. The rotor is made up of several magnets, and when the rotor spins, the magnets pull electrons through the copper coils, generating an electric current. For a motor, the coils in the stator would receive power, which would spin the magnets in the rotor. In practice, generators are usually attached to a turbine. A turbine is a device which can convert moving air, gas, or fluid into rotational movement. Examples of generators and turbines used together are wind turbines, which uses wind, hydroelectric dams, which is fluid, and nuclear power, which is gas. My system used an alternator from a car. Alternators are used to charge the battery and power the systems inside a car. In order to get an alternator to generate power, it needs to be excited. This is because alternator rotors use electromagnets rather than permanent magnets. To excite the alternator simply means to activate the electromagnets. The alternator needs to receive 12 volts while spinning at a high RPM to be excited. Those 12 volts were delivered to the alternator by connecting a battery to the terminal on a side of the alternator with a switch. Once the alternator is excited, it becomes much harder to spin because the magnets are on. Here's a video of my system working, and when I flip the switch, you can actually audibly hear the alternator turn on. In order for the battery to charge a phone, it needed to be limited to 5 volts so that it doesn't overcharge the phone, which was done using this voltage regulator. The bike is mounted to a bike stand which is fastened to a wooden structure. I also made a wooden stand to stabilize the front tire. The rear tire is replaced with a belt which is used to spin the generator. The alternator is bolted into the wood with metal brackets. My system was successfully able to charge a battery, and the battery could charge a phone. However, the alternator was extremely difficult to spin and did not generate that much current. The rider would struggle to keep the alternator excited and generating power. Using a permanent magnet motor would be much more suitable for a system like this. When the belt was connected to a motor from an old washing machine, which does use permanent magnets, it was able to generate up to 1,000 volts in AC. Pedal-powered generators aren't exactly the most practical way to generate electricity for our everyday lives. It takes a lot of effort just to power something as simple as a household appliance, which is probably why people don't really use bike-powered generators in their everyday lives. After this, I hope to design a more practical form of energy production, such as one that utilizes wind or steam.